Ever stop and think about what's going on like thousands of miles straight down from where you are right now? Because it's not just rock and dirt. Deep down, there's this incredible furnace, a source of heat so immense it has literally shaped our entire world. So, let's get into it.
And this is really the heart of the mystery, isn't it? It just sounds impossible. How can the center of our cool, rocky planet be as hot as our star? It's a fantastic puzzle, and in this explainer, we are going to piece together the answer.
Okay, just to put a number on it, we're talking about 10,800 degrees Fahrenheit. I mean, that is just staggeringly hot. It's almost impossible to even wrap your head around. So how does our planet stay that hot?
Well, here's how we're going to tackle this. First, we'll take a quick journey down to the center of the Earth. Then we'll look at the 3 big reasons for all that heat. And finally, we'll see why this whole internal furnace thing is so unbelievably important for all of us up here on the surface. Ready? Let's go.
Right, so before we can really get the why, we have to understand the where. So let's start our descent layer by layer down to the very heart of our planet. Our trip begins right here, on the crust. It's this super thin, brittle outer shell. You know, if the Earth were an apple, the crust would literally be no thicker than the skin. That's it. That's everything we've ever known.
Okay, let's push through the crust. We are now in the mantle. This is the biggest layer by a long shot. It's this zone of hot, semi-solid rock that's constantly churning and flowing over millions of years, kind of like a super thick, incredibly slow-moving soup.
And now we're getting close. We've just reached the outer core, which is basically a swirling ocean of liquid iron and nickel. And believe me, the fact that this part is a moving liquid is, well, it's a very big deal, and we'll see why in a little bit.
And here we are. We've made it. The very center of the Earth, a solid ball of iron and nickel just glowing with mind-blowing heat. This is our destination. This is the source of the mystery. Now, let's figure out why it's so incredibly hot.
So our first major clue, the first reason for all this heat, isn't actually something that's happening right now. It's more like a ghost from the past. It's all the leftover heat from when Earth was born.
Scientists have a great name for this, the heat of formation, or you might hear it called primordial heat. It's basically just the leftover energy from when our planet first smashed itself into existence. So try to picture it. 4.6 billion years ago, our planet was being built by just countless collisions of space rocks, dust, you name it. Every single impact was like a massive explosion, generating a crazy amount of heat. Then, as the planet got bigger, gravity started pulling all the heavy stuff, like iron, down to the center. And that sinking process created even more heat from friction.
And all that heat got trapped deep inside the planet, with the mantle and crust acting like a giant thermos. So a huge chunk of the heat we see at the core today is literally just the leftover warmth from a bonfire that was lit at the dawn of our solar system.
Okay, but leftover heat from a bonfire, that can't be the whole story, right? I mean, heat escapes. The Earth should have cooled down a lot more by now. And that brings us to our second clue. There's something down there that is constantly generating new heat.
And that something is called radioactive decay. It's happening everywhere, all the time in tiny amounts. You have these unstable elements that are naturally breaking down into more stable ones, and when they do that, they release a little burst of energy as heat. Now, just imagine that happening on a planetary scale.
Because it turns out the Earth's mantle and crust are just seeded with these kinds of elements, especially uranium, thorium, and potassium. And they're just constantly decaying, 24/7, all across the planet.
So you get it, right? While that ancient bonfire is slowly dying out, this internal engine is constantly adding new fuel to the fire. It's this continuous source of heat that has kept our planet's interior blazing hot for billions of years. All right, so we've got leftover heat, and we've got newly generated heat. But there is one more piece to this puzzle, a force so immense it's hard to even picture. This is our third and final clue. It all comes down to pressure. Just the sheer weight of the entire planet. The crust, the mantle, the outer core, all of it is pressing down on that inner core. And that creates these just mind-boggling levels of compression. When you squeeze something that hard, its atoms vibrate like crazy, which generates an enormous amount of heat. Just think about that for a second. Millions of times the pressure that you're feeling right now. In fact, this squeezing is so powerful that it's the reason the inner core is solid, even though it's technically hotter than the liquid outer core around it. The pressure is just too high for it to melt. So yeah,
The weight of the entire world is acting like a giant cosmic pressure cooker, squeezing the center and cranking the temperature up to those sun-like levels. So there you have it, our three sources: leftover heat from formation, new heat from radioactive decay, and intense heat from just unbelievable pressure.
Okay, so we've cracked the mystery of why the core is so hot, but the biggest question of all is, why do we even care? Well, it turns out this internal heat engine is the power source for pretty much everything that makes Earth a living, breathing, dynamic planet.
That heat escaping from the core is what makes the mantle churn, and that's what moves our continents around. It's the engine behind volcanoes and earthquakes that are constantly reshaping the surface. But maybe most important of all, that swirling liquid iron in the outer core, powered by the heat, that generates Earth's magnetic field. This invisible shield protects our atmosphere from being blasted away by the solar wind. Without the core's heat, we'd be a cold, dead, unprotected rock, kind of like Mars.
And that really brings us to a final, pretty heavy thought. This isn't just some cool science trivia. This is the lifeblood of our planet. If that internal furnace ever did go out, that protective magnetic shield would be the first thing to go, leaving us totally exposed to the harshness of space. It really makes you think, doesn't it? Just how fragile this beautiful world really is, all of it powered by a hidden furnace deep beneath our feet.